Yo, all right, here we go. Let's rock and roll and do these problems. All right, so when doing these today, I'm going to kind of take our time and talk about the rule that we apply every time. So, in other words, here I have y equals arc cosine of stuff, and I want to take the derivative. So then I'm just going to make a note. That means we're going to use the rule for the derivative of arc cosine of stuff, right? So, what is that? The derivative with respect to x of arc cosine of, instead of writing stuff, I'm going to write u is going to be negative 1 over radical 1 minus stuff squared, u squared, times du dx. That's it. That's the rule. So when I go to do dy dx now here for this guy, all right, I'm going to follow this procedure. So this stuff here, this is my stuff. This is my u, so to speak, right? So right there, that's my u. So I'm going to get negative 1 over radical 1 minus parentheses 2x plus 1 squared. That's the 1 minus u squared times the derivative of u with respect to x. Well, u is 2x plus 1, so the derivative of that is just 2. And quite honestly, that's a fine answer. But when you go to look in the back of the book, sometimes they mess around and they do things. So we're not going to get too bananas with this, but maybe we'll just do a little bit. So we got the negative 2 up top, at least, very least, write it as a single fraction. And now we're going to get radical. So now think about this. You're going to get 2x times 2x, that's 4x squared. So I'll have negative 4x squared here, right? Because there's a negative in front. You have 2x times 1, 1 times 2x, that's 4x. All right. So there's a negative in front, so it's still going to be negative 4x. And then you have 1 times 1, which is 1, but the 1 and the minus 1 sum to 0. So this is what you get. I know I didn't show all that work, but write this out twice and distribute it, and that's what you're going to get. So now the interesting thing about this is I could be cute here and say, hey, you know what? You got negative 2 over, couldn't I, if I felt like it, factor out, I'm just going to factor a 4 out here. So factor out a 4 and get negative x squared minus x. So all I did was pull out the 4. You're like, why didn't you pull out the negative? I didn't want it. All right, so I just pulled out the 4. So the reason for that is because now I have the square root of a product, which is the product of square roots. So I can write this as the square root of 4 times the square root of negative x squared minus x, right? Hopefully you're seeing that. You're like, well, what was the point of doing all that? Well, because what's the square root of 4? Square root of 4 is just 2. So this is going to be able to cross out with that. So I'm actually going to be a little bit lazy here and not rewrite it as 2 and just say, all right, you're going with that. And so now my final answer is going to be dy dx, and it's going to equal negative 1 over radical negative x squared minus x, and that's good enough for me. The idea, though, is you're going to do one line of calculus, like get to this point here, and think, oh, or even this point here, and think, all right, I got it. And then you go and look in the back of the book, and this is what they have. So you have to know how to do some of these algebra manipulations. All right, so let's go to question 2. So again, we can't let this mess us up. That instead of y and x, it's s and q, right? So here we found dy dx. Here we're finding ds dq. But even before then, let's think about what we're going to use, right? So what's the rule here? This is arctan of stuff. So the rule that you're supposed to memorize is that the derivative with respect to x of arc tangent of stuff is going to be 1 over 1 plus stuff squared times the derivative of stuff. So that's the rule we're using. This is our u. Now, technically, I guess since it's u, a q, and not x, I should have said d dq here, but hopefully that's not going to screw you up. So here we go. So let's do ds dq now. And so now arc tangent of stuff, it's going to be 1 over 1 plus stuff squared, u squared. Now your stuff, or your u, guys, is q squared. So it's going to be 1 over q squared squared. And then times the derivative of stuff. So the derivative of q, right, with respect to q. All right, so what does that end up being? That's just going to be 2q to the 1. And this one's pretty simple, cleans up nicely. It's just going to be 2q up top, and at the bottom, 1 plus q to the 4, right? So there's no fancy schmancy stuff that we're doing with radicals here. Okay, so just be careful with the s's and the q's. Don't let it mess you up. someone's going to ask me, can I just change this to a y and change that to an x? And my answer is, please don't do that. Just deal with the s and the q. The more you do it, the more you get used to it. Now, should you see it as just a y and an x? Yeah, that's how you see the structure and the pattern. But you should be comfortable using the different variables. All right, let's take a look at this guy. Arc cotangent of stuff, right? So what's the story there? Again, I'm going to think about, well, what rule am I using? So I'm going to use that rule that I just gave you. I didn't derive this one, which is the derivative with respect to x of arc cotangent of stuff, right? Oof, arc cotangent of stuff. It's going to be negative, begins with a c, so negative 1 over 1 plus u squared times du dx. So it's very similar to the arctan of 1, it's just negative. So this here is my u, right? So you're like, all right, dy dx, now I'm going to do it. Dy dx is negative 1 over 1 plus u squared, or stuff squared, but what is u? U is radical x, so radical x squared, and then times the derivative of u, times the derivative of stuff. Well, stuff is radical x, and I told you memorize that one. The derivative of that is 1 over 2 radical x. And again, this one's pretty nice, cleans up pretty simple. So you're going to get negative 1 over, maybe I'll write 2 radical x first, and then times 1 plus x, right? Because radical x squared is just going to be x. All right, so you end up getting that. Nice clean version, nothing too bad. And so now this is where if I was live, I'd say, okay, you do this one on your own right now. So why don't you do this one on your own? Hit pause and do this one on your own. All right, you're back. Hopefully, I didn't fool you. Hopefully you didn't, treat this as inverse tangent of stuff, because it is not. This is an actual exponent, right? That guy's an exponent. So this really means r equals 1 over the tangent of theta. It's another way to write this. You're like, how do you know? Just by the way it's written. Here, that negative 1 is implying inverse cotan. Here, with the parentheses outside, right, this is implying that it's an exponent. So you could do 1 over tan. You want to take the derivative of that. You can go ahead and you can say, hey, you know what? I'm going to use the quotient rule. Or you can be like, why don't I rewrite this? This is just cotangent of theta, right? Because I have that one memorized. So dr d theta here, what is the derivative of cotangent of theta? It's negative cosecant squared theta, right? Derivative of cotangent x is negative cosecant squared x. And that's straight up memorization. If you wanted to, right, you're like, I didn't see that rewrite tricks, but I did know it was an exponent. So when you went to do dr d theta, maybe you did the power rule. You're like, this is stuff to the negative 1. So negative 1 stuff, right, to the negative 2 times the derivative of stuff. The derivative of tangent theta is secant squared theta, right? So maybe you ended up doing that. So now, all right, let me take a look at what's going on here. All right, if I use some identities, let's take our time with this a little bit. Here's this negative, no big deal. This is going to be 1 over tangent squared theta, right? That's what this would be when I rewrite it as a positive exponent. This is secant squared theta, right? You with me? And you're like, all right, well, then I can go ahead and write 1 over tangent squared. That's just cotangent squared theta. This is secant squared theta. And then maybe, running out of room here, maybe write the cotangent squared as negative cosine squared theta over sine squared theta, because that is the quotient identity. Whereas here, this is 1 over cosine squared theta. And you're like, oh, take a look at that, right? I can actually cross these factors out, and I end up getting 1 over sine squared theta. And 1 over sine squared theta, guess what that's equal to? That's equal to negative cosecant squared theta, okay? All right, so you could have did it that way as well, however you saw it. All right, so we got a couple more problems here. This is what I'm gonna do. I'm not gonna actually play the video for these. I'm gonna stop the video here, and I want you to finish these, and then you can check the answer key later, and then I'm also gonna assign a couple of textbook homework questions. All right, see you later.